So, agenda for today is that we will discuss the purpose of methane detection tools, why they became popular at the moment, what tools are available, and what SPH can provide to detect the methane. And Alexey Yankelevich will show how methane detection data can be processed. And of course, we will answer some questions. Why methane detection tools are quite popular at the moment? Of course, we all want to have good environment around us, clean air, but main driver in terms of investments from why companies around the world invest into additional tools for gas and methane leaks detection. Answer is quite simple. It's a quite strong regulatory requirements, most of all in developed countries like United States, in European Union countries. And you can see how strong can be control and the pressure from regulators. So here are just a few examples from latest news from United States about fines for landfill operators and oil and gas companies for methane leaks. Fines can be absolutely, I don't know how to tell, 9 millions for methane leaks. It's huge. And what are most, I don't know, not popular, but distribution of sources of methane leaks? First of all, that's oil and gas companies. Around 30% of all methane leaks related to that industry. Next is enteric fermentation, and third is third group of methane leak sources are landfills. We have as a customers, we have companies from oil and gas industry and landfill operators at the moment, and all our customers made decision to invest into new technologies, first of all, because of increased pressure from regulators. So how to avoid such fines, such bad things? Recipe is very simple, actually, is to detect methane leaks and eliminate them as soon as possible. For that purpose, airborne tools mounted on the drones are excellent because you don't need to deploy ground network of sensors. You don't need to conduct repeatable terrestrial surveys. Drones equipped with sensors can cover huge areas in very short time. And why we are speaking about detection? What is the difference between detection and measurement? Because maybe a most popular question regarding the methane detection, methane leaks, is about possibility to quantify or to measure amount of methane which is leaked in the some time. So, for example, in liters per minute or some pound. So, I tried to explain on the example using that AI-generated images. So, what is the detection? Detection is here when you notice something bad. So, we will die in 5 minutes. It's a typical estimation. But measurement, it is quite precise value what can be determined directly. In that case, using clock, but it can be some measurement device which measures what we want to measure. In regards of gas leaks, so if we need measurement, absolutely precise or values with some known accuracy, we need to use measurement tools like here. Detection using airborne sensors, all airborne sensors, laser-based sniffers, optical gas imaging cameras, they are detectors because they don't measure how fast is leak in direct form. For example, laser detectors can give you comparison actually. Here is more concentration of methane is higher than in the other area. And concentration is methane is above some threshold. But we cannot measure the leaks. In between are some methods of estimation or quantification of the leaks. But at the moment, they are kind of black magic because they require a lot of measurements or detections, plus additional data like data from wind sensor, data about humidity. They require some complex and not very proven, not very tested algorithms, and we will get some numbers as results. And main problem in all methods of estimation or quantification, what we know, is their not predictable accuracy. So what we propose detection, not measurement and not quantification. That's all from my side. Alexey Kadek, stage is yours.
As Alexey mentioned, on the market exists different technology how to detect methane. So there is some methane chambers, stationary system, fixed detector, portable gas detector used by ground crew, sniffer, or sensor based on the TDLS technology. But today's topic is to talk about airborne solution. So, and we will discuss mostly TDLS-based solution, and as well on the airborne, in the airborne solution exists sniffers, OGI cameras, and thermal cameras. So for this solution, there is different use cases. So TDLS solution allows you to detect methane remotely, so and do it quite fast because with a, for example, with a laser falcon, you can fly 4 or 5 meters per second and cover quite big area during the flight. So methane sniffer is more let's say precise device because methane is measured inside the sensor, and you will not and sensor will not be sniffer measure more precise because all measurements will be done inside the sensor, and any weather condition or something will not influence on the result. So, and preferred method is OGI cameras, which can provide you with visual image of the leak. So, and but this method is more useful if it's stationary mounted. So one more thing that TDLS technology measure in ppm in meter, and sniffer measure in ppm. So there's some different in naming and in measuring. Let's proceed. Today we will talk about SPH methane detection kit, which based on the Pergam laser falcon. Here is some picture which clarify how system is working. So during the flight, sensor sent laser beam to the ground and receive some reflection. And if there is some methane, methane absorb some part of the laser beam, and sensor understand that methane is presented in this area. So main parameter of the system. Recommended altitude for the laser falcon is 20-30 meter. So line spacing is from 10 till 30 meter, but this depends, of course, from the area, from your scenario, and can be different. So in some cases, if you need to get high resolution of area, then of course, like spacing need to be between 2 or 5 meters. So because a laser falcon has quite high measurement frequency, you can fly from 5 till 10 meter per second, but normally recommended fly speed is around 4-6 meter. So, but yes, here you can choose what is better for your scenario. So sensor measure, as I mentioned, measure methane in ppm in meter, and sensor is quite sensitive. You can sensing range is from 1 till 50,000 ppm. So our system is compatible with DJI UAVs, and not only. We tested with US-made drone like Inspire Flight, Harris Aerial, and Whisper Ranger Pro. So in our methane detection bundle, main part of integration is SkyHub onboard computer. This computer designed by SPH Engineering to log data, get telemetry from the drone, and if you use DJI drones, SkyHub will allows you to fly in terrain following mode. This part is quite important because to measure methane concentration, you need to fly with constant altitude, because as I mentioned before, we measure concentration in meter, and if you will change, if altitude will not be constant, then measurement can be useless. So and last but not least is the laser falcon, which is provided by Pergam company. So it's specially made sensor for UAV. It's the sensor is without GPS, batteries, or internal storage, just to remove weight as much as possible. And all this data will be recorded to the SkyHub. One more part of our kit is software. Regarding UgCS mission planning software, you can fly fully autonomously without it's not necessary to do flight manually. So you can upload digital elevation model in case if necessary, but if you are use terrain following mode, then this is not so important. So UgCS custom payload monitor allows you to see real-time data during the flight, so you can always understand if the sensor working, and in some cases you can even see place of the leak and make additional flight in this special area. Benefits of this solution, of airborne solution, is efficiency in area coverage, because you can repeat flight each day or each month if necessary, and use the same road to cover area very precisely. Next is safety, because in some cases in hazardous area, you cannot send ground crew to make inspection, but drone can easily fly over hazardous areas. So precision detection is quite important, because you need to clearly understand where is a methane cloud, and thanks to SkyHub, you will get telemetry from the drone. So, and all data will be all data will be with GPS coordinates. So one more thing is operational flexibility. So you can create road for special areas, and you can easily fly away from some obstacle or some object which in manual flight can influence on the flight safety. So, and one more thing is price. Price for the stationary equipment is quite high, but for the airborne solution is quite cheaper. So of course, there exists some limitation. Laser technology can be used over the water. Sensor should be orientated to the ground perpendicularly. In some cases, altitude limitation will influence, but normally, if we speak about landfill inspection, then 20-meter, 30-meter altitude is good enough. And here I will mention once again, our equipment is fast scanning tool, and you cannot quantify amount of the methane. So yeah, now we are working over new with the second generation of the Falcon, and we are working over gimbal version of the sensor, so which provide you more accurate, more stable data. So, and we hope that this will help to get more relevant data and provide additional inspection method. For example, if you cannot fly over the area, then you can fly from the side of this area and change angle of the laser Falcon and make this inspection from the side.
Now let's speak about data processing. Indeed, as you could notice, actually the main purpose of methane laser detectors is provide the fastest possible screening method for a potential leak location. And actually, but what's next? When you collected data, the data itself, I mean, it's not very interesting, because in the case of the sensor and the SkyHub, you just get like a CSV file with sensor readings, and depending on your drone setup, you have either just latitude and longitude along with methane measurements, or if you use RTK based system, then you also have like a second pair of coordinates, like latitude RTK and longitude RTK. But of course, I mean, I would say we hardly can call this data actionable because you know, it's just raw data from the sensor, so you need to make several steps to make kind of a report that one can pass to a field team. Because after screening, of course, the second step is validation using either handheld equipment or just approaching the location of the potential leak for visual inspection to understand what happens. Either it's like just some damage for the landfill cover, or you see some unauthorized excavation works near the pipeline, etc., or I don't know, some problem with wells, etc. So actually, the goal is to build actionable map which can be delivered to a field team. But let's just spend maybe just 1 minute for learning the structure of the raw data. So as I already said, the result of data recording is a CSV file. That's what one can get from a SkyHub on board computer. Depending on the area size, it can be just one file, or it can be multiple files if it took several batteries to cover the entire area, meaning that you had to fly the drone, then swap the battery, turn it on and off, etc. And this is how this additional files can be generated. But in any case, you grab all this data, and every single file has the following structure: latitude, longitude, and also gas methane and gas status columns. Gas methane is basically a reading. This is like methane reading. Gas methane is, as already was mentioned, it's a path integrated measurement, ppm along the distance. Gas status is the confidence level from the sensor. There are several levels of confidence, but most usable statuses are 0 and 1, which indicate that the reading is reliable. There are also other statuses which can tell you that, for example, the strength of the signal was too low, or the reflection was too high. So in most cases, it's just a good indicator of some false positive. And during our processing pipeline, we take into account all the specifics of the data structure. And of course, we also analyze the drone trajectory just to select optimal values and to minimize the chance for false positive. So let's then move forward. What happens next? So after you collected files, then you go to the project inside Drone.js. I'm not going to explain a lot about Drone.js right now, because basically it's a cloud-based platform for managing different map layers for the site, oil and gas site or landfill site. But in this particular case, we will use the functionality dedicated to process data from SkyHub. For the Drone.js, most probably shortly, we will have a separate webinar. So in this particular case, what we do, the processing also has to be very fast to deliver results to the field team same day as you collected data. So you need to perform very simple steps. First of all, you just upload data to the system. And here we support various types of data, but now we are interested just in CSV files from SkyHub. So we have a separate selector for sensor data, CSV. On the next step, we specify where we want to upload this data. So to which layer? You can, I mean, those people who work a lot with GIS systems, there is nothing new here for you, because we also operate, we deal with different kinds of layers. And after data uploading, we will have two layers. We will have raw data, and the software also will automatically generate heat map. So the first step is to select the target layer name. Also, we need to specify the sensor type. We support different types of sensors right now. As you can see, we support Falcon version 1, Falcon version 2, and also some other sensors. In this particular case, we have data from Falcon V2. Also, we want to specify the target GSD for the thermal map that will be generated after CSV data processing. We have also several advanced options here, which help you to process data properly depending on the way the data was acquired. So for example, we distinguish between two modes. For example, if you collect data for the area, like a landfill, we can select area. Otherwise, if data was collected along the pipeline, then it should be track. And also we have option which helps you to filter data not belonging to actual flight lines, but for example, if it belongs to takeoff, approach to the actual survey area, and departure from the survey area. Then the second step is actually selecting files. I'm not going to waste time for uploading data and some server-side processing, so I pre-upload this before our webinar. So let me show how it looks like. So first of all, let's check the raw data. The flight was over a relatively small area, and you can see that it's more or less a regular pattern. So we have measurements with regular grid, but this data is not very informative. So the most informative view is the actual heat map, which is generated based on the collected sensor data. And on this heat map, we clearly see the area with this red color where potentially something is wrong. And also we have two more subtle areas where also seems like the presence of methane exceed the ambient methane level. So actually heat map is a great way of representation what happens on the area of inspection. And actually this already look like an actionable data. What we can do next? So first of all, I will disable just raw data because we don't need it now. So what we can do? One of the typical questions is how to make the heat map a bit more visually attractive and also filter values above a certain threshold. Because of course, in the air, there is some methane already. And depending on the area, the ambient concentration can be very different. So to make it picture more clear, we can say that, for example, we want to specify ambient values to 600, or like a more common value 200. So that filters out a lot of variations in data. So the data, like values which are below the threshold, they become, in our case, just blue. And higher and readings with bigger values, they get more and more clear. Actually, we can increase, and you will see that amount of noise will be reduced. So now it's even easier to read and actually to locate where the methane concentration is higher than the average methane level for this area. What we can do else? In the platform, we can also configure different color palettes. And I would say that doesn't affect the actual readings. That's more like a visual effect, and depending on the local practices in the company, you can just select the appropriate color palette. Also, we can configure transparency. So for example, if you have the orthomosaics, or if you have the technical drawing of the site, you can also add these layers to the same map. In this particular case, we have RGB map behind the heat map, so you can clearly see that, okay, the leak happens somewhere on the road. There's also one advanced feature that can be used for better visualization. Let me switch to another color panel. Sometimes it can be also useful. For example, if you want to see small variations on the heat map, sometimes you may enable hill shading, which makes this small variations distinguishable, and you can clearly see them. I would say for methane detection, maybe that's not very popular for function, but sometimes you may want to highlight these small changes. But okay, how we can deliver a report to field team? So we see potential spots, and let's just mark them. So I create just another layer, and I will drop 1, 2, and 3 spots, and then confirm changes. And also, for example, I can just change the color for better visibility. Let me maybe switch to another palette. Okay, now maybe it's a bit better. So we have 3 spots. For each spot, we have, when I move my mouse, I see the actual measurement here. So now I want to deliver a report. We can do it easily. So we can share the prepared map using either, you can send a link, and the field person, I mean, they can just open this link and they will get access to the drone.js software and will see the same view as I do. Or if you don't want to provide access to the cloud account, then in this case, you can simply download Microsoft Word report. So let's see what we get. And here is simply what we configured in the application. So we get a picture of the map. We have our 3 spots. And for every spot, we have geographical coordinates. You can also add additional comments. So this is a Microsoft Word document, and it's a draft. So you can add a logo of your company. You can add additional comments. For every spot, we show coordinates in geographical, like latitude, longitude. Also, we can add some projection if you work in any specific PSG zone and you want to have X and Y instead of latitude and longitude. Also, you see the methane reading for that spot. Again, you can add additional comment, and you can share this report as is by email, by WhatsApp, or whatever mean you prefer to a field personnel, or you can modify it. basically, this is it. So the whole idea behind this solution was that we want to provide a convenient tool and convenient workflow for the team searching for leaks. And based on our experience, in certain situations, it may work as follows. So there is a drone pilot which approaches sequentially one site after another, collects data, then delivers this data immediately to data analysts using this cloud platform. And data analysts uploads this data to the platform, slightly adjusts heat maps, and delivers report either to a customer or to third person who makes actual validation in the field. And the whole idea is to make as much work as possible during single working day. Collect data, process data, and deliver report. That's all from me. Thanks a lot. So I'm
Alexei,
I'll stop sharing. Yes.
please show, not stop share, please show how 3D visualization looks. Here is the question about possibility to 3D visualization.
Okay, answer some questions, and I will just switch to another data set. So I will pause my screen sharing for a while, and meanwhile you can answer a few more questions.
Alexei, Kadak, there is a group of similar questions regarding the alarm threshold value. May you comment live, please?
If, for example, in the United States, everything what is higher than 200 ppm, you should remove this leak. So, but for the pipeline, to be honest, I'm not sure what is like alarm for threshold.
Okay, just here, I hope you can see my screen again. So I opened another example where we combine the same data with actually a few more layers. So we have a 3D model, have a point cloud, and we have method measurements on the same map. So this is how it's possible to combine to make a 3D visualization. I would say that sometimes it looks cool. I mean, practically speaking, for most of the field personnel, of course, Microsoft Word report is sufficient. But yeah, I mean, 3D is always like, it looks much better than 2D. And maybe another reason why it can be useful is when you have some vertical structures, which can be expressed better using point cloud. In this case, such a combination can just help to better understand the potential location of the leak.
Maybe you can, you know, something more about different thresholds for different types of surveys. Question from Michelle.
What's the proposed alarm threshold value for a gas pipeline inspection? So in this particular, so what I can say is that now most of the use cases that we have, not we, but our clients have, they use post-processing. So you always process the entire set of data, and then you see relative values. So this means that first of all, you always find for the hottest area along the pipeline. And this is how you classify leaks. So in most cases, you do not use it's very hard to specify like an absolute universal absolute value for the threshold, because in different areas and also in different seasons, the ambient methane concentration can be different, you know, just because of vegetation in autumn, like, or some other natural conditions of the place, type of soil, etc., etc. So the main method is finding the hottest point for the area, hottest points for the area, and along some path. I think there is also a question about IF 1200. Would the mounts work for these types of aircrafts? And I see that Alexey Smirnov is typing the answer. So
yeah, but the same mounting snow, because IF 800 is smaller, so it should be modified. So, but it is possible.
There's also a question from Milan. Is it possible somehow to have picture from the detected place? You mean that, so as I demonstrated, so you can combine methane detection data with other layers like orthomosaics, or for example, if you don't have orthomosaics, you might have, for example, a Mapbox satellite layer, which you can combine together with methane detection and adjust transparency of the methane layer. So this is how you can see actually what the place is, and I mean, see some visual signs. What is this place? Also, if you have a camera on board which takes still pictures along the flight as well. So yes, in the software, you can combine image gallery with methane detection map. So, for example, you can see the picture from the still camera, even if you don't stitch these images into orthomosaics. So if that was a question, then answer is yes, it's possible. So two methods, combining with orthomosaics or combining with image gallery. Of course, these images should have georeferencing, but for most integrated cameras, images have latitude and longitude in EXIF data of the JPEG file. If the camera is kind of, I don't know, old-fashioned GoPro, yeah, there might be no georeferences, but that's a rare case these days, for sure.
How is it possible to measure background noise? Mohammed.
I mean, it's there are several techniques to extract background noise. In our case, in our processing pipeline, actually the background values that are visible when we build heat map. And this is how you can like just adjust the palette, the heat map slider, and see when the most of the noise disappears. But of course, you can apply different averaging and low pass filtering techniques just to calculate the background noise for the specific area, if needed.
There is a question from Michal about the sunline affecting the measurements. Could you tell us more about that?
Yeah, what are you? Okay, we have some experiences that when we have sun during lunch, we have higher noise. And to me, it makes sense because, I mean, if when sun is the highest, topmost position, then this means that the amount of sunlight getting into the sensor is the highest possible along the day as any laser. Such kind of sensors, they do not like direct sunlight. So I think that makes sense.
And the picture of the detected pin position, you already answered that question, right, Alexei?
I hope so. So I can just remind that you can combine methane map with both word mosaics and with picture gallery. So I hope that that's what you mean, saying pin.
All right, thank you. And there is one more question, but I can see that Alexei Kadek is already typing an answer to this one. The readings from the Vulcan. And I think if that's all for the questions. We want to thank you for participating, for watching, and you can always contact one of us with the questions. And thank you very much for participation.